Well, we're good? Yep. Hello, let's do this. Hello, everybody. How is everybody doing today? Not enough. How is everybody doing today? Let's talk about React security. So who here is a React developer? Let's do this, folks. You know, does anybody here think that React is automatically resistant to cross-site scripting? Does anybody think that React, it has security built in, just use React and you're secure? Who thinks that? Raise your hand. You're wrong. There's at least 5 major techniques we need to master in order to build secure React applications. Be careful of dangerously set inner HTML. Be careful of props and types they don't escape. Be careful of JavaScript URLs. They will execute even when escaped in React. Be careful of older versions of React. And one more we'll come up with in this presentation. Let's get to work here. My name is Jim Manico. I'll be your presenter today. I'm an author. I focus on security engineering. I don't code as much. I do architecture, which means I sit in my ivory tower and tell other people how to code. It's a terrible career. But what I do is I'm trying to teach developers to write secure code. Nobody cared about this a couple years ago. And now, who cares about security today? Raise your hand. Everybody. Yes, that's the right answer. Let's get to work. Yeah, there's a warning. Don't hack stuff. Let's talk about the risk I worry about when we talk about React. I'm worried about cross-site scripting. I'm worried about the attacker being able to inject JavaScript into your React app that didn't come from you, that came from the attacker. Cross-site scripting. So what I can do is I can build a URL that has JavaScript in it, send it to a user of an application that uses React. This evil JavaScript will execute in the victim's browser, and from that point, I can do many things. I can steal data, steal the cookie, deface the website, trap all keystrokes, steal your tokens, and more. So that's reflective XSS when the attack is in the URL. When the attack is in the database, I submit some content to your application. Maybe there's a comment system or chat system that we're all chatting back and forth. I submit my chat to the insecure application. Somebody else looks at that chat message, and my evil JavaScript lands in their browser, and now I can steal data or worse from that particular user or users. Now, let's look at some of these attacks. A lot of people don't care about cross-site scripting. They think it's just academic, and they're wrong. Here's the kind of things I can do when, as an attacker, I can get JavaScript into your application that's from me, the evil attacker, not from you, the noble developer. Here's the most classic attack. It's a cookie theft attack. Again, imagine I chat this to you, and you render this message in your browser. I build a URL to my evil website, and I grab a copy of your cookie and URL encode it so it fits in the URL. Now, this is happening in your browser, victim in your browser. I now have a URL with your cookie in it, and I then make a new image object in JavaScript. It's just an object on the DOM. It's not visible. And I go preload it, send your cookie to my domain. What happens if I can steal your cookie in a normal web application? Out loud, what if I can steal your cookie? What does that mean?
You can post as the user.
I can now, you're exactly correct, Peter. I can now, once I steal your cookie, I can submit requests as if I was you, as if I was the victim, the owner of that cookie. This is called session hijacking. This is a way I can take over your account at least until you've logged out. And if I could make this cookie HTTP only, this document.cookie would return an empty string. Now, HTTP only is a defense we talk about for a lot. And there's no reason why in React you can't use cookies. I prefer cookies for security. So even if I can't steal your cookie, with JavaScript, I can make your application submit any request that I want to. In this case, I have XSS against a webmail system for your corporation. I'll just make an AJAX request back to your mail system and send a mail to your boss and say, you're a jerk, boss, and that's it. So even though I can't steal the cookie, I can force a user to conduct any action with cross-site scripting or with JavaScript injection, a better name. And even if this cookie was HTTP only, or if it was the same site cookie, a new security flag, or if it had token binding, it doesn't matter. When I get JavaScript into your website, all those defenses are useless, and I can start attacking your application as if it was your code. That's what cross-site scripting is. Let's see if we have any others here. Let's look at this one. So in this attack, I have the bad team, a team that you do not like, any other team. I randomly make fun of the team. Your team shoots worse than my mom, and my mom is Sicilian. She kicks ass. And then down here, document, body, inner HTML. Anybody know what document, body, inner HTML does in JavaScript? What does document, body, inner HTML do in JavaScript? It overwrites the entire page. So again, when I get evil JavaScript into your website, I can build a keystroke logger, trap all your keystrokes. I can deface any part of the website. I can steal any data from the website and more. This is something, if you care about security, we've got to take seriously. So let's figure out how, there's a defacement. Oh yeah, here's the keystroke logger, right? So here I am building another attack code. I grab a copy of your password. I use the same image trick to steal that password until the user logs in successful. This is another way I can steal password data if I get XSS into your login form. A lot of people want to filter this. They want to build some magic firewall to stop these attacks. That's bullshit. That's not, fix your code. That's what I'm here to tell you. Don't depend on other defenses to save you because they're only partial defense. You need to fix your code. You need to write secure code intentionally from day one if you want secure software. Who wants secure software? Everybody else raise your hand. We all want that. We need this for a modern society. And JavaScript is an insane language. There's so many ways I can represent an attack. This attack has no letters, so I can evade filters. This attack has no letters or numbers, so I can evade filters. Look at this website, and this website shows you many ways I can hide JavaScript from a filter to evade your defenses. So building input validation or using a web firewall, they help a little bit, but they don't solve the problem. And we're here at JFocus to solve problems. That's what we're going to do. So here's an attack from Gareth Hayes. It's called a polyglot attack. It's both a JavaScript URL, a comment, a title, a style, a text area, an XMP block, and it will execute this attack payload no matter where you put it in the website. Here's an attack from Mario Heinrich and Chris Christowitz, two of the top researchers in this area. Here we're going to show the login form, fetch your login form, and then rewrite the login form, the text, and we'll replace the action of your form with evil.com. So I pop your login form and rewrite the destination to evil.com. You're logging in, but you're giving me a copy of your password as I redirect you back to log into your normal website. Do we have to take this seriously? Say yes. Say yes, Jim. Say it. Yes, Jim. Good answer. By the way, Bitcoin is all a big international fraud to steal money from the foolish. I'm one of them. So here, if I get JavaScript into your website, like maybe through an advertisement or through a large website with many users, I can use CoinHive to do Bitcoin mining in everybody's browser and soak up their resources through cross-site scripting or malicious advertisement. Bitcoin's a big bleeping scam. Get out and do real investments. Anyways, let's just move on. This is my personal pain when it comes to Bitcoin. And here's a real keystroke logger, right? I'm just trapping the key down event and using a WebSocket to send every keystroke to my server. Okay, let's talk React now. So securing React components, it may sound unnecessary. Didn't the authors of React build security in so it's automatically secure? The answer is no. The Facebook team for React, they built some security into React when they authored different components, but there's a lot of things that can go wrong, especially when you're using JSX, right? This is the markup that transpiles to JavaScript before it runs in your browser. And the JSX converts calls to the React create element function. Let's take a look at that. So again, React is a relatively new library today. And since its release, researchers have found a number of different violations in the library, a number of ways they can take even a relatively well-written React application and still attack it with the evil JavaScript that I was showing you just a few moments ago. So when you're building React, you need to do 3 different defenses based on the situation, right? 3 different defenses based in the situation. For some kind of content, we have to do validation. For other kinds of content, we're going to escape. React does this escaping automatically in some places, and it doesn't do the escaping in others where it should. We also need to do data sanitization in some places, like when you're using dangerously set inner HTML in React to turn off escaping. Let's look at these 3 examples, try to get us very specific examples of this, right? And again, I want to show you the complete formula here. If you're a React developer, that's great. But if you're a React developer who really understands React security and you're willing to show this to the rest of your team, you're not just a React developer, you're now a React user interface security architect. Does that sound like higher or less pay? It's higher pay. Capitalism isn't so bad. I prefer socialism. Don't get me wrong. I'm sorry. Ignore that. Ignore that, please. Let's move on. We're moving on. Bad joke. So let's start by protecting React from standard content injection like we were just looking at. So when you create a React component, you're normally going to use straight up JSX syntax. This is going to convert calls to, again, React.createElement. When you build a web application with React, it's going to run the React DOM.render method to place your React component into the web browser's DOM. So when you use createElement to create an element and later call React DOM.render to put that element on a page, it performs some escaping on the values. And when I have a piece of data and I escape it in the browser, it neutralizes the attack. It turns off the attack, so the attack is visual, but it doesn't actually execute. And so when you do this escaping, it converts quotes, double quotes, ampersand, less than symbols, and greater than symbols into their HTML entity. So if I have a less than symbol, it's code. If I have ampersand LT semicolon, it's just display data. So the whole purpose of React defense, the automatic defense, it's auto-escaping. It will auto-escape any content to prevent it from executing JavaScript. But there are ways I can get around it as a security researcher. Let's look at this. So again, React DOM.render, even if you decide to pass something dangerous into the 3rd argument of React createElement, which will then call React DOM.render, this will automatically get escaped. When this lands in your browser, it executes whatever that payload is. When this is in your payload, it doesn't execute in your browser. It will show that data, but it won't actually call the script. So that argument is gonna actually escape, but the types and props here are not gonna escape. This is one of the main ways we can attack React. So first of all, React createElement, the prop or type values do not escape, and they're dangerous if dangerous data flows to those variables. Go look at your code right now if you want to. Dangerously set inner HTML. That disables React's escaping, and it directly populates inner HTML with your markup. What if I get JavaScript code into inner HTML? What happens? It just parses, renders, and executes. So this function in React, is that safe or is it dangerous? It's in the name. It's living dangerously. And we'll look at a way to handle this. Also, when you're putting data into a URL, like an action or a form submission or other URL, we know there's HTTP URLs. We know there's HTTPS URLs. There's also a JavaScript URL that will execute whatever content is in that URL. And this still will execute even if it's escaped properly. So if I take a URL, escape it, and it's a JavaScript URL, it's gonna execute. Also, lots of the cascading style sheet helper function in React, they take the first 2 prop and types and they're not gonna escape. Any early version of React before 0.14 is easy to attack, and a lot of people are still using older versions of React, which is a bad idea. Keep everything up to date. And last, when we're embedding JSON in a React application, we have to store it in a safe fashion. The actual React documents gives you bad advice that's going to be dangerous. So let's get into the details now. Let's get into the weeds of this code and how we can build it in a more secure fashion. This is the first way that I violate React. But before I go too much further, I am a little bit tired today. Is it okay if I have a quick fika before I continue my talk? Is that okay? Let's have a little fika. Want to have fika with me? Come on up. Would you like water? Yeah. Water? There we go. Would you care? Cheers. Fika is important in Swedish society to help refresh the mind, to see things from a better perspective. Are you a fan of the fika?
Yeah, the perspective is much better here.
It's nice up here. Cheers. I have to get back to work. Would you excuse me? Thank you. All right. I feel better now. Nobody was amused by that attempt at humor. I thought it was a hilarious comedy. Did you enjoy your fika? You're still working on it. All right. So let's look at this now. Here's the JSX code where I'm saying ahref is some link that I'm letting the user author. This looks familiar to everybody? Like maybe they edit their profile and they're putting it, and one of the profile elements is a home page, right? Home page. And so and this is what the user types in for their home page. By the way, is this a legal URL? Say yes, it is. And this will execute even if I escape. This is the main way I am able to bypass React security. I just do a search in all your code for href equals open tilde, and that's almost always going to be a URL that if it's not validated properly will lead to cross-site scripting. So, and why this is so frequent is because developers assume that React will protect you. It does escape, but again, an escaped URL still leads to a vulnerability. So here we go. Here's another place where this attack payload will launch. Here I have another JSX code. I have a button, form action, and my payload. That's untrusted data. This is not going to be escaped in the example, so I have to validate to make sure this is both a legal URL and it's JavaScript, and it's not a JavaScript URL, and it's properly escaped. So this gets dangerous when you're using a type or prop as part of dynamic code development. So, and again, this is unfortunate. This is a big problem with React. What I recommend you do is build this. So this is a React component that does URL validation, not up on your server, not at your API, but in React itself. If you want to be a master of React security, then your React application should be immune to cross-site scripting regardless of what content is delivered from the server. So a lot of people will defend up on the server, do validation. I do that, but never depend on it. Every single defense we talk about should be in React itself, so React self-defends against these types of attacks. Here I'm saying, is this a safe URL to render? Like here, return the href is safe payload, or drop a null there. And I'm saying if the protocol is HTTP, good. If the protocol is HTTPS, good. Anything else, let's reject, like a JavaScript URL, FTP URLs, all that will get ignored. So now it becomes impossible to give React anything for this component other than a legal, safe HTTP or HTTPS URL. That's security technique number one in React, and it's pretty straightforward. I also like to do validation on the server when users first submit these URLs to me. So I have validate URL in Java. I'm using the URI class to make sure it's not absolute. I'm only accepting HTTPS, and I'm normalizing the URL at the end. Some security people don't like the normalize step. What they say is if the original URL doesn't match the normalized URL, then reject it altogether. I think that's fair. But I'm just trying to get rid of path traversal tags, like a dot dot or a dot dot slash. Anybody who gives me a dot dot slash in a URL is doing something to attack me. They're trying to evade some kind of URL security. So I'd probably replace this, not just get rid of those path components, but if the normalized URL differs from the original one, I'd probably reject it flat out. Just discussing it. So that's number one. Let's validate to make sure URLs that are authored by a user is not a JavaScript URL. The second place where things go wrong is when you're using cascading style sheet different components in React. Anybody see what the problem is here? Where's the vulnerability in this code? Right there. This is cross-site scripting inside of cascading style sheets. Can you, if you let your user author evil cascading style sheet, can you do an attack with just CSS? Say yes. Yes, good answer. Right there. Check, this is crazy. This is a keystroke logger in CSS. A keystroke logger, I'm just stealing a copy of all of your keystrokes to steal sensitive data, passwords, or whatever from you. So I need one of these for every letter. So I'm saying the password field, when the value is A, then go load this background image, and it's just sending a URL to the letter A. Then I have another one for B. See, every letter I want to trap, the style will detect it and send a message to my server that you just clicked on that letter. So the point I'm trying to make, if you let a user author cascading style sheet, we can use it in dangerous ways. How do I fix this? Well, I want to escape it. I want to use a CSS escaping routine that keeps that color to hexadecimal. It's a CSS hex encoding is the encoding format for CSS. So we'll use a standard CSS library, we'll escape that color, and regardless of what attack gets to that color, we've diffused the attack. That's defense number 2 that you need to master within React. Any questions so far? So far, so good, everybody? Not that difficult of a formula, I think, but it's obscure, and you need to understand this as a secure React developer. The next thing that comes up is the need to add raw HTML inside of a React component. Now, overall, this is usually being a lazy developer. I like being lazy, don't get me wrong. But you largely should not be moving HTML around the DOM. You should use things like create text node, other programmatic ways of building your markup. But sometimes we have things like a WYSIWYG editor. And like let's go to, like for example, suppose you're using TinyMCE. This is a JavaScript component that turns a text area into a WYSIWYG editor. You can make text bold, use bullet points, different colors, embed images. When you hit submit on this piece of content, it's going to be a large chunk of HTML. And the goal is for this HTML to be displayed to other users. So here's my question. When you allow a user to author HTML, why is escaping not going to be a helpful defense? Let me ask the question again. When you are allowing a user to author HTML, why is escaping not the right defense? Anybody? If I escape this content, what's the user going to see on the page? They're going to see plain text source code. Good answer. You're going to be safe, but when you're using a WYSIWYG editor, this is what you want the user to see. So the question is, when I'm allowing a user to author their own HTML, how do I make sure that there's no evil JavaScript or other content in that HTML? Anybody? We want to use some kind of sanitizer. And so let's take a look at this. So again, when you're allowing a user to author HTML and you go to Stack Overflow and say, how do I get my HTML to work in React? React, the Stack Overflow will say, use dangerously set inner HTML. It will disable your auto-escaping and everything will work just fine. This is horrifically terrible advice. This is dangerous. We want to do more than just give this advice. We want to use some kind of sanitizer. Now, where are we going to find a sanitizer? It's not built into React. There is one built into Angular, however, and it uses basically this library. Welcome to DOM Purify. DOM Purify is probably one of the most important JavaScript libraries when it comes to security. Why is that? So what DOM Purify does is it takes any content here and it cleans it up. So all the dangerous content will go away. It's really that simple. This is written by Cure53, a company that specializes in this particular kind of defense. The team that built this library are some of the top researchers in this area. And there's been a few people who found mistakes here, and they rapidly fixed these mistakes in this library. So I recommend, if you're going to do dangerously set inner HTML, to automatically send that content through dompurify.sanitize, and please make sure you keep these libraries up to date. This is anytime you're doing JavaScript work, whether it's server side or client side, your number one security mission is to keep these libraries up to date at all times. And very few of us do that. And by the way, why is this difficult? You use NPM, right? When you grab one library out of NPM, how many other libraries get pulled down? In some cases, many thousands. The security of NPM is technically known by a certain name. Remember what that name was? What would you call the security of NPM?
I think it was a shit show.
For the recording, it's called a shit show, a show of shit. Forgive my language, but this is true. The chance that we can control the security of now 900,000 libraries in NPM is very low. The NPM security only tells us there's a couple hundred vulnerabilities in NPM that's not even close to being correct. And many of these libraries are so complicated that we can't even use security tools to analyze them properly. So please keep your libraries up to date. And so again, if you're doing dangerously set inner HTML on any content, that's a security violation. And if you're doing it with DOM Purify, this problem goes away. That's your third defensive strategy to build secure React applications. So far, so good? Yep. Let's keep going. Let's talk about safe handling of JSON next. One of the performance patterns of user interface development is not to do an initial AJAX request to fetch your initial content, right? And so what we see React documentation suggesting is to take your initial JSON and just embed it in window initial state or window preloaded state. What this will do is, instead of doing a round trip to grab your first JSON, that round trip gets eliminated. And we can preload the initial content to save like a fraction of a second or two in rendering. This is a good idea if performance matters to you. And this will, again, saving that round trip is always a good idea. However, much of the documentation for React says that when you're embedding JSON, to use a stringify function. What stringify does, it takes this JSON and renders it directly as plain text. So if my JSON was nscript, script, alert, XSS, these double curly brackets get ignored by the browser, and now I end the script, add a new clean script, which executes, and now my JSON, which you stringify to embed, will cause cross-site scripting. So we cannot use stringify when dealing with JSON in the browser. It is not secure. Anybody know what we need to do to lock this down? You want to serialize your JSON. This is the Yahoo serializer. It is still kept maintained and kept up to date to this day. I do not know of another JavaScript library that does this. I don't like recommending Yahoo products for you to be using, for just my opinion here, but this is the best out there that I know of in the world of JavaScript. So what it will do is it will serialize the JSON for your initial embed, and it will actually escape all the characters so your JSON can't do anything malicious. This is the fourth technique. Embed JSON with security in mind. I'm going really fast. I've had a little bit too much coffee today. Does anybody have any questions about anything we've talked about so far? Any questions at all? Peter? No, Jim. Thank you for helping me out there. All right, let's move on. Let's look at third-party components next. Remember the proper term. This is NPM, right? Here what do we have? We have Maven. This is also a shit show of security. I don't mean to say that cruel to Maven, but how many insecure libraries are in Maven today? Millions, right? And what has the caretakers of Maven done to alert us when we download insecure libraries? That would be nothing. They don't care. Go ahead, download insecure libraries. But if you want, buy our products. No, that doesn't help. So I really believe that the curators, the caretakers, I won't mention the company's name. That would be rude, Sonatype. But the folks who run Maven, they treat it like a file repository, and it's a cesspool of insecurity. It's caused billions of dollars of damage around the world. Like Equifax was hacked because they pulled down an insecure library out of Maven. Maven could have done a simple alert. Hey, that's insecure, by the way. Something, but they don't. They want you to buy other products. And I'm not a fan of this. We need more responsible curators of the Java ecosystem when it comes to third-party libraries. They got to go. We need someone else who cares about security, not just for their commercial company, but for the entire community. That's my take on this. And NPM is even worse because it's growing so rapidly. There's very little chance we're going to get good security here. So when you're grabbing a React third-party component, what's the chance that's perfectly secure? The answer is very low. So just because a component has a couple stars on it, it doesn't mean someone has done a good security review of this component. And we want to make sure that we're using automation to verify that the JavaScript we're using and all of their dependencies are updated and not vulnerable to these cross-site scripting classes of attacks. So I want you to add some checks into your development pipeline every time you build, every time you deploy, every time you check code in. I recommend that you use the retire.js from one of our good friends from Norway. I can't pronounce his name well. Erland, great developer from Norway. He's a Java developer. He's a JavaScript developer. It's an open source library which you should run. Are we doing pictures? A lot of pictures? Pictures. Wait. Get me in this. Pictures. Come on. Pictures. Go. Okay. Tweet that out for me, please. At Manico. There's my Twitter account. Hit me up with Manico. And I'll publish this library. I'll publish these slides at the end of my talk so you all can grab a copy as well. But say thank you to the author of this. This is one of the few open source tools that will let you analyze your application and detect if you're using an old JavaScript library with security issues. The other thing we have is NPM's audit. This used to be a third-party company, but they bought that company and they're working hard to integrate the security team into NPM. So before you grab a library and start using it, run an audit check on it to look at its security history so you have an idea of what you're getting into. Last, I'm a big fan of NodeSource. I'm hesitant to mention NodeSource on stage here, but it's not the company, it's the concept I want you all to consider. NodeSource will look at all the JavaScript libraries, they'll do their own security testing of it, and put those previewed libraries into a separate repository that you as a developer can just use and not worry about. This, I think, is the future of secure development. Because if you just start grabbing stuff out of NPM, it's a what is it again? Shit show of security. And this is a epidemic problem in software development because of how much all of us depend on third-party libraries to do security. Is that fair? And so let's look at some versions of React here. Let's look at some versions. So any version of React prior to 0.14 is completely vulnerable to cross-site scripting. Now, Do you think people still use React 0.14? Extremely large number of people do. When React went beyond version 0.14, it was a major paradigm shift, and you had to re-engineer lots of your application. So people who are early adopters of React, they built on 1.4, things work, and then the migration to the next version was unfortunately extremely painful and difficult to get right. So I still know of a lot of companies who spent thousands of hours building on 0.14, and they're hesitant to move to the next version because of how much work it takes to upgrade for that particular version upgrade. So what I can do with React 1.4 is I can just set is React element to true, and that will turn off the escaping, and I've bypassed all your security. It is really, really simple, unfortunately. So again, what you can do is use a sanitizer. If you're somehow stuck in React 0.14 or earlier, then if you're stuck in React 0.14 or earlier, you can run DOM Purify over every single variable and protect even your older React applications from being attacked in this way. And this is I think it's a bad defense. We shouldn't have to run a full-fledged sanitizer through every piece of content. This is just a special situation where you're stuck on an old version because you don't have the time or resources to upgrade. That's the formula for React. Let me finish up by showing, and by the way, if you have questions for me, I'm jim@manico.com. I'm always happy to answer questions about secure coding. This is the topic I specialize in. I don't code so much anymore. I focus on researching security and doing tests for security. 10 years ago, nobody cared about this. Today, it's become extremely important to the well-being of modern society, right? The kind of hacks that we see in the real world today are more damaging than the global illegal drug trade and other forms of crime. So because Western society, because all of society depends upon software to run infrastructure, to run banking, to run everything we do now, the fact that so much of our software is insecure, it's beginning to put pressure on society in ways that are very uncomfortable. It's affecting politics and elections and banking and infrastructure and everything that we do or do not hold dear to us. We've got to write secure code. And as a developer, who here as a developer has pressure on them to write secure code at their job? Like a few. That number is only going to go up over time as these incidents continue. Anybody work in a world where they are never asked to care about security as a developer? Nobody's willing to raise their hand. All right. Let's take a look at, before we go any further, before we finish up, let's take a look at DOM Purify. Let's see what's going on here in DOM Purify. Hang on for 1 sec. Don't worry, I'm a professional. Let's go jump on this network here. Please don't hack my phone without a good lawyer. Let's go visit DOM Purify. Let's go see this in action is what we're going to do. Nothing like a live demo over a cell phone. Come on, Chrome. There we go. You're a very quiet audience today, very quiet. Still digesting your own fika? So here's the library, right? And let's look at the source code for a moment. Let's go look at the source code. View page source. The way that you use this library is very straightforward. I take any content and just call dompurify.sanitize. And now I can safely put that content into inner HTML, outer HTML, or any other JavaScript assignment that will take HTML. If you just put JavaScript into inner HTML directly, that was driven from an attacker, it's just going to execute when the page is rendered. So let's see how DOM Purify Sanitize works. So if I up here, if I say something like, thank you. If I do something like, my favorite tag. I'm old and gray. I'm old, decrepit and gray. So I still use H1 tag. I'll say, hello, from Hawaii. Yes, I am from Hawaii. Aloha. Someday when I do a conference, I'm going to have my private jet waiting on the airport and take everybody to Hawaii with me as part of the talk. That's my dream. Physics doesn't really back up my dream, but who cares? Hello from Hawaii. So when I submit this as content and I run it through DOM Purify, they're like, this is great. No problem, Jim. That's all good. So let's do this. If I say like on fika equals, that's an event handler that doesn't exist, by the way. And I'll do an alert just to prove it. Let's see, hello from Hawaii 2. Let's see what that does for when I sanitize. Boom, sanitize. See, look at the difference here. Hello from Hawaii 2, but this unknown event handler was removed. Let's try one we know. On blur. That's when you mouse over an element, it will run the event. Let's do hello from Hawaii 3. Sanitize. Boom. Hello from Hawaii 3, but it ripped out that event. Anybody want to try a bypass? What should we try? Shout it out, please. What's that? Absolutely. So I'll say href equals, let me show you this run first. So I'll say Java, JavaScript. People are like, why are you doing a JavaScript talk at a Java convention? Well, JavaScript. Sorry, that was a terrible thing to say. Back in history, Sun Microsystems and Netscape were debating, and like the head of Netscape was like, "Yeah, I'm gonna call it JavaScript. This is great." And Sun was like, "Please don't do that." No, like Java. That's all. So anyways, just moving on. All right, where am I? JavaScript. I'll say document dot body dot inner HTML equals every. Let's do a nice marquee H1. Everybody fika. And I'll just end it without finishing my tags. If that hurts you, I'm sorry. Let me see what I did wrong here. So there, let me go back. Hang on, let's go to DOM Purify. Hang on, don't worry, I'm a professional. Let's go to DOM Purify. I have to be on a page for this to work. There's my attack. JavaScript colon document body inner HTML equals single quote marquee. I'll just do this. H1, everybody fika, and that should work. Yeah, simple, right? So let's do one more. I gotta do this right. I'm sorry. Hang on. Don't worry, I'm a professional. No, I'm not apparently. I see. See, when you paste, it strips out the JavaScript URL. They're trying to protect. Doesn't really work, but I'll type it back in. Let's make sure I get this right. JavaScript document, everybody fika. There we go. Now I'm happy now. We're everybody fika now. So we get the idea. JavaScript URL can launch an attack. Everybody believe me now that I can use a JavaScript URL to launch an attack? All right, good. Hello. So let's do this. There's my attack. And what should I call this? Yeah, everybody fika. I like Hawaii. It's very warm. When I read that fika is protected under Swedish law, I'm like, ooh, maybe I should move. Who needs the warm beach? By the way, do you ever see TV about Hawaii and they show warm weather and beaches and everybody's in bikinis and bathing suits and everybody's happy and there's coconuts? You see that on TV, right? That's exactly how it is. So I just want to let you know that is how it is. Sorry, that was a bad joke. Yep. I was so excited about my story. I'm sorry. Does that look good? Yep. Let's sanitize it. Boom. Let's just so I show you I'm doing it right. I'll make this number 4 and sanitize. And there you go. It ripped out the whole attribute. Now but wait a sec. Let me prove it's actually working correctly. Don't give up yet. So let's grab the actual attack and instead go to https manico.com. We'll call this 5 now and sanitize. Yeah. Other protocols get through. So if you can bypass this and get JavaScript to execute, you're doing a great job. You've bypassed one of the most important security libraries in JavaScript. This is so important of a library They're going to include it in the next version of ECMAScript as a native library in JavaScript. I think this is a great idea. You cannot develop secure code without using a sanitizer, and I believe this is the best. I am done with my talk. I'm really happy you came here to let me talk to you about React security. I'll make sure I publish this talk through JFocus. You can get a copy. If you can't get it for some reason, just send me email and I'll send you a link with the copy. Does anybody have any questions before we finish up this talk? Please ask me a question.
Did you sleep well tonight?
I slept for, I got in at 5 a.m. The airport was a little stuck. I slept for 16 hours last night, so I feel quite refreshed. I needed that sleep. I flew in, I landed in Stockholm at 5 a.m., got to my hotel at like 5:20 a.m., got 2 hours of sleep, took a shower, and then did a 3.5-hour workshop. Thank you, coffee. This message brought to you by coffee. But seriously, anybody have any questions about secure coding, about React security, or about cross-site scripting before we finish up? Yes, sir. Can you talk in the microphone, please? Someone hand him a microphone. Little messy fika there. Just shout it out, and I'll repeat the question. Content security policy. Always use it. I'm waiting for the question. You should always use it. I recommend that you use the strict dynamic policy of Content Security Policy 3.0. How much time do I have? I have more than 5 minutes, right? 3? No. Then we have fika. Okay. XSS defense. I'm going to show you the kind of policy and presentation that you should be listening to. Here it is right here. All right? Absolutely use content security policy, but you're better off using it from the beginning of your project. If you try to add it in later, it gets complicated. But of all the policies, I want to recommend those of you who really want to do rigorous security in the user interface, go look at this presentation from 2006. It's from Michel Spagnuolo or Lucas Weichelbaum. The title is either something you really love or you really don't like. It's called Making CSP Great Again, whatever. But this is before the election, so no politics. So here's the URL here, right? I highly recommend you look at this presentation. These are two of the best experts in the world. They're not people writing the standard. They're people who are implementing the standard at all the different projects within Google, and it's very well done. It's getting really difficult to attack Google properties. And what they're suggesting is to use a CSP level 3 policy with the nonce, so you can add noncing to embedded scripts. It says strict dynamic, so you don't need to individually add every single path to the library. What it says is if you have a script that's nonced, then just go grab the entire hierarchy automatically. We can't protect you anyways. And also stop running plugins. All like Flash and client-side Java will all be shut down here, which is good for web security, unfortunately. And as you use an older browser, that's CSP2, strict dynamic doesn't work. So it will nonce, and it will allow any path to be loaded with libraries. Because this is older browsers. The point is, I can build one policy. As it degrades to older browsers, everything still works. And if you have a really old browser, CSP level 1, very rare, it's going to allow all unsafe inline and any content to run. It will still turn off plugins like Flash and client-side Java, but what this does is it lets me degrade to older browsers with a simple policy. I recently was teaching at one of the larger pizza companies in the world, and as I'm teaching this in class, the main engineer at the beginning of class pushed it live to the dev server. It passed all their development checks. So at the end of the class, he was like, "Let's do it, Jim." And he pushed it live to like the entire world, and it was just fine. So, that scared me a lot. He's like, "Let's do, what's the worst that can happen?" Boom. No, but there was like 20 QA people who were looking at this in the QA team as he did this. So this is how I would do content security policy. So if you do make any mistakes in React, which is going to happen as it gets more complicated, this will stop the attack from launching. I am now done. What time is it now, everybody? Fika time. Thank you so much Enjoy the conference.